Everybody look up at the overhead.
We're looking.
You're looking. What do you see? There's two problems.
One's opposite.
There's addition and subtraction.
Okay, one has a subtraction. What are we asking you to do in these two problems?
Solve it.
Simplify. Solving it is when you get an answer, like x equals 5. You're going to be solving when there's an equal to sign. There's no equal to sign. You're just going to simplify these. So in other words, make it simpler, smaller, shrink it. Now, what's the rule for adding? First of all, this is called a trinomial, right? This is a trinomial. We'll call this problem A, and we'll call this problem B. In problem A, we have a trinomial, and in problem B, we have a trinomial. What's the rule for adding? These are three terms here. How do you know if you can add the terms? What do? You combine like terms, I heard. How do you know if they're like? What do you look for?
They have to have the same bases,
Same
and
base.
it has to have like the same exponent.
Good job. So what would you do then in order to simplify this problem?
You would make it 7x squared, a plus 2 plus, oh, wait.
I heard 7x
Well, you
squared.
can combine all three of that, right?
Yeah.
So it would be 8x squared.
Now, where did the 8 come from?
There's an imaginary one.
There's an imaginary one. 8x squared. So this trinomial turned into a monomial. Okay? Now, the only thing different about this one is instead of 5 plus 1x squared,
Minus 1.
it's 5 minus 1, which is 4, and 4 plus 2 is
6.
So that's the only thing I wanted to show you on that one. Okay? Now, I'm gonna see if you guys can figure out the rule for it, because we're not doing these types of problems today, we're doing radicals. If I gave you this problem, 5 root x plus 4 root x, does anyone think they know what the answer is?
9 root x.
9 root x, you guys just figured it out, and I didn't even have to tell you. Now, what if you saw this? 5 root x plus 4 cube root of x.
You can't add.
Why?
I like to use
The index are the
cube
same.
squared.
The indexes are different. Well, what about this? 5 root x plus 4 root x squared. Did I do that?
No.
No. So you are telling me that you know how to do these problems?
Yes.
Yeah.
Yes. Okay, so first of all, this use of vocabulary, just really quick, can you tell me monomial, binomial, trinomial? Is this a monomial, binomial, or a trinomial?
Trinomial.
Awesome. How about 5? Is this a monomial, binomial? Monomial. How about the next one? Bi, and then we have a tri. Good. So now, read this where it says 8. To be like radicals, their indexes must be what?
The same.
The same. And their radicands, so let's talk about, what's the difference between an index and a radicand? The index is referring to what? These two little numbers right here. So you told me if they are the same, and if they're radicands, that's what's underneath here is the same, then you can go ahead and combine them. Otherwise you can't. So you have just created the rule. To be like radicals, their indexes must be the same and their radicands must be also
The
The
same.
same.
the same. So if they both are the same, to add or subtract them, what are you going to add? Are you going to add their radicands or their coefficients?
Coefficient.
Good. The coefficient is the number in front of the radical. Awesome. Okay, so let's try problem 1 together. Everybody.
Can't do it.
Why not? I heard can't do this. Why can't you do this?
Are the same.
Cube root of x squared.
The same.
this is a cube root, this is, so their indexes are not the same. So is the answer no solution?
Can't simplify.
It's simplified, exactly. It's 7 cube root 5 minus 4 square root 5. That's the answer. You can't get any simpler than that. Now, if this was a cube root of 5, what would our answer have been? If this said 7 cube root 5 minus 4 cube root 5, what would you have told me?
3
the answer?
cube root 5.
Yeah.
Mhm. Okay, how about this next one? Look at it for a minute before you shout the answer out. What do you think that one is? Ask yourself, are the indexes the same?
Yes.
Yes. Are the radicands the same?
Yes.
Yes. So what are you gonna combine then?
It's gonna be 7x squared.
7x squared?
Cube.
No, just,
It's gonna be cube.
just seven.
What is 3x plus 4x?
Seven X?
It's just 7x. Do not combine the powers. So it's just simply 7x and then square root of xy. Is everyone okay with that?
Yeah.
Okay. In about 5 minutes, you're gonna be doing these, practice these for homework. But go on to this next one, this next example in the notes. So, what do you have? They want you to simplify this one. Now, before you say you can't simplify it, you need to apply what you learned in section 6.1. That's why I feel it is very important to do each section than to skip it. Because if you don't do 6.1, you're gonna struggle with 6.3. You can't do this section. You need to know how to simplify each one of these first in order to be able
Is there a
to.
way you can
Can we
add them?
combine them and then simplify?
No, you cannot, right now, they are not, their indexes are the same, but what's different? They're radicands. But in a minute, I'm gonna make their radicands the same.
Oh, I know.
Okay, so what do you think you should do?
You just gotta break everything up until the radicals are the same so you can
You
combine.
got it. So how would you break 250 up? So this is what I would do. Off to the side, I'm gonna take a closer look at 250. How can I break up 250? What two numbers? Just throw
25
two.
and 2.
25 times 10,
Oh.
okay?
Yep.
Can 25 be broken up?
Yeah.
5 times 5. Can 10 be broken up?
5,
5 times 2. So look what we have here. 250 consists of 3 5s and a 2. 3 5s and a 2. So, how many of a kind am I looking for?
It's 5 and 2.
3, and so it's 5, you take that 5 out, times the cube root of
2.
2. Okay, so what we did, this is what you did on section 6.1. Okay, we're gonna keep going. How do you break 54 up?
27 and 2.
I heard 27 and 2,
You can take the cube root of 27 and 2.
27 and 2, and you can break up 27 into 3 times 3 times 3. Okay? So 54 consists of a 2 and 3 3s. Now I'm writing this all out. Some of you guys, whoops, I want to write it here. 3 3 3. So what comes out now? That 3, so this would be 3 cube root of 2. Okay? So this 3 comes out, and what stays is the cube root of 2. Last one. Check out what we have so far. I'm going to predict that this is going to be something cube root of 2. I'm just going to predict it. Let's see. Just because based on these are the same here. So, how do you break 16 up? That's an easy one to do in
2
your head.
cube root of 2.
2, 2, 2, 2, and yep, it's 2 cube root of this 2. So now can you tell me what to do?
Yeah, you can have like
Are the
6.
indexes the same?
Yeah,
Yep,
6 root 2.
and so you're saying it's 6 root 2. Can you explain where the 6 came from?
5 plus 3 is 8 minus 2 plus 3.
if you did not do section 6.1, you're gonna wanna do 6.1 first before you tackle these problems right here. Okay? And one more, go to the next page where it says problem 4. What does this remind you of? What does that remind you of?
Foil. Foiling.
Foiling, yep, foiling. How do you foil?
First
First, outer, what do you do with the first?
Wait, what number are we on?
We're on problem 4 on the next page, in the middle.
Oh.
Problem 4. So, I heard foil,
Yeah.
Would you explicit?
okay? I made this up. I just made this up. I just wanna review old stuff.
X times X is X.
It's X, he said the magic word, X times X. FOIL stands for what?
First outer and
First
last.
out.
You multiply the first two terms, you multiply the outer, the inner, and the last. Okay, remember that? So what do you think you're gonna do with this? It
Same
involves
thing.
radicals.
Same thing.
You're gonna do the same thing. You're going to multiply the first two. What are the first two? Let's just write it out first.
3 times 6.
3 times 2,
Is 6.
which is 6. I'm gonna write 6 in a minute. Okay, then what do I multiply?
3 times 4 root 5.
3 times 4 root 5, and then what?
Then 2 times 2 root 5 times 2
2 root 5 times 2, excellent, and then the last one.
is 2
2
root
root
5
5
plus
times
2 root
4 root 5.
Yeah.
Okay, now let's do the multiplying. You said 3 times 2 is 6.
Yeah.
What is 3 times 4 root 5?
12 root 5.
Yep, and you did this in section 6.1 and 6.2. So again, if you didn't get that down, you gotta be able to do those before you can do 6.3. Okay, anyone know what 2 root 5 times 2 is?
4 root 5.
Mm-hmm. And the grand finale. Don't
Uh,
shout it out, think first.
Okay.
Make sure you know.
8 root 25.
8 root 25 is close. Is there a better answer?
Well, 8 root 5 after you solve it, because then,
8
no, 8
root
times
5?
5. 8 times 5 is 40.
40.
40.
I heard 30, I heard 40.
It's 40.
It's 40.
It is 40.
It is 40.
It is 40.
I heard it is 40.
8 times 5 is 40.
Let's all raise our hand if we think it's 40. It's 40. Why is it 40? Because
you break up 25 and 5 times 5,
Yes.
then you break up 5 as 1, and then
Yeah,
5 times 8.
you got it. Okay, now, is this the simplest we're gonna get?
No.
No. Can it be simpler?
Yeah.
What?
Add the 12 root 5 and the 4 root 5.
And what do you get?
46 plus
46.
plus 16 root 5.
You got it. Now, believe it or not, see this problem? You've done like 5 concepts here, if not more. I could think of more. This is a loaded problem. That's why people hate math, is because they get lazy somewhere down the line, they skip a section, but guess what? You can't skip a section in math. You have to do all of it, because at some point, you're gonna have some missing, you're gonna have holes in your knowledge, and it's not, the better you do on each section, it builds, you're giving yourself a good foundation. So, people, it's very important in math that you do all of the work progressively. That's how you're gonna be most successful. Don't skip a section and think that, oh, well, I'll just, not understand this. It's gonna show up somewhere again. It will.
How'd you get that again?
How did I get this again?
I didn't see.
You guys tell me how you got this. You guys got it.
40 plus 6.
Add like terms.
And then,
These are like terms,
Oh,
and then the
okay.
middle are like
Oh, okay.
terms.
and these are like terms. Why are these two like terms?
Because they have the
They have the
same
same root.
radical and the same index.
So is this the simplest we're gonna get?
Yes.
Yeah.
It sure is. What I want you to do for the rest of the time is to go up to problem 28. See this problem 5 right here? We are going to do this tomorrow, Thursday. Guess what tomorrow is?
Oh, I hate those ones, 'cause you gotta multiply.
September 11th, 9/11. So tomorrow, we're gonna do the rest of this page in the back. These will all be on YouTube. Mr. Duke, do you have anything to add?
So what numbers are we doing for over?
You're gonna do all of the ones we did up to 28.
10 to 28.
Does anyone have any questions?
This stuff is easy today.
It's easy today, good.
Yesterday was kind of.
You know why it's easy? Because you've actually learned something, believe it or not, you've
I
learned.
so lost yesterday.
Hang on, can you turn the video camera off?
18 hours out.
Yeah.